All right, we're going to transition from our videos on counting to actually starting a unit on probability itself right now. And this video really just includes a bunch of definitions with some examples along the way. So it's not your typical math video where we'll be solving problems, but really just talking about some ideas, giving some definitions, and some basic ideas related to probability. So let's get started. The informal definition of probability is something I'm sure you all know. It's really just the chance that something will happen. Is there a 25% chance something's going to happen? 75%? Is it 50-50? Probability is just the chance or the likelihood that something will happen. 0% means we think it will not happen. 100% means we think it's guaranteed to happen. There, however, is a formal definition of probability, and there are many other specific formulas for a variety of circumstances that yield probabilities as well. But in general, I think the most fundamental one, although this has some caveats to it, is that the probability of an event, and we abbreviate that as P of E. P stands for probability, and E is whatever the event is, so we can write in those parentheses what the event might be. But the probability of an event E is simply the number of ways that E could happen, that event could happen, divided by the total number of possible outcomes. Okay, so let's say you're rolling a die and you're wondering about the probability of getting an odd. Okay, so how many ways could you get an odd number? 3 of them. You could get a 1, 3, or 5 when you roll a 6-sided die. And how many total things could happen? There's 6. Okay, so the probability of getting an odd number is 1/2. All right, the biggest caveat with this is that all of those events happen to be equally likely. So if it's an unfair die, then you can't use that formula, okay? And then you might need to use some other methods to determine the probability of rolling an odd number. Perhaps roll that die 1,000,000 times and see how many times you get an odd number. There are some very strict bounds on what the probability of anything could be. And this is telling us that the probability of any event has to be between 0 and 1 inclusive. Okay, inclusive means that 0 is a possible answer and so is 1. And in the world of percent, that means that the probability of a particular event has to be between 0% and 100%. You can't have negative probabilities. That is an impossibility, and that would be weird to think what that would even mean. The chance of something happening is negative 20%. I don't even know. You can't have probabilities over 100% or over 1. So you can't say the probability of something, you can't say the probability of some event is 1.2. Can't do it, okay? You also can't say the probability of some event is 120%. Those would mean the same things. 1.2 is the same as 120%. So those violate math law. Can't do them. Okay? 0 and 1, those are our bounds. There are different ways of representing probability, and if your teacher doesn't specify exactly which way they want, I think it's up to you how you want to represent them. Fractions, decimals, or percents. Okay? Although with fractions, I really think that you should reduce the fraction down. So rather than having 4/10, I would reduce that down to 2/5. You could write that as a decimal as well, 0.2, and you could write that as a percent as well, 40%. Right? So either of those are valid ways of representing probabilities. Just some more vocabulary, some more terms we'll be working with. The sample space is the list of all the possible outcomes that could happen. What's just a list of everything that could happen? And I'm going to run through one particular example here. And that is if we were to flip a coin 3 times. Okay, what could happen? Or maybe we're flipping 3 different coins once each. What could happen? People often write the sample space in these curly brackets in set notation. I don't think it's particularly required unless your teacher asks you to, but I'll follow math convention and do that. So we could get 3 heads in a row. We could get a couple heads and a tail. And those couple heads and a tail could happen in a variety of orders, right? We could also get a couple tails and a head. And lastly, we could get 3 tails. Whenever I teach this, students are often a little bit frustrated with asking to write out the sample space. It sometimes seems somewhat tedious, somewhat just brainless, busy work maybe. But I think it's valuable to look for some patterns. And you see that when I wrote mine out, I sort of gradually increased the number of tails. And so I looked for a pattern, and I thought it wasn't so bad. I thought it was sort of like solving a puzzle. Okay, so I encourage you to be okay with writing out the sample space. So let's say we are curious about what's the chance of getting 2 heads if we were to flip 3 coins at a time. So one thing you could do is you could do an experiment, okay? And then just do that a million times. Maybe program a computer to run it. Maybe get a whole class to flip a whole bunch of coins, and then just see what you get, okay? So an experiment is just doing a whole bunch of repeated trials and seeing what the probability is, and that will yield experimental probability, okay? It might not be what the ideal world probability is, but it will give you certainly a very good estimate or sense of what the probability is. So that's what an experiment is, just doing a whole bunch of repeated trials. A particular event, what that refers to is an outcome or a set of outcomes. So when we're talking about the probability of 2 heads, and when flipping 3 coins, maybe that's what we're curious about the probability of. The event is getting 2 heads when flipping 3 coins. That's the event. That's the outcome or a set of outcomes. And in this case, you can see it's a set of outcomes because there are 3 different ways of getting 2 heads. Okay, so that's the event we're curious about here. So the theoretical probability, we're just going to use that formula, and I'll copy down the formula that we had above. This is really one of our most important formulas to know. So the probability of something is just the number of ways that thing could happen divided by the total possible outcomes. So let's find the probability of getting 3 heads. Or 2 heads. Oops. How many ways could that happen? Well, let's go back up to our sample space. It could happen in 3 different ways. Okay, so there are 3 different ways of getting 2 heads. And how many total different things were there that could happen? 1, 2, 3, 4, 5, 6, 7, 8. Okay? So it's going to be out of 8 possibilities. So we just use the formula, right? The probability of getting 2 heads is 3 out of 8. The experimental probability, you could, like I was saying earlier, you could flip a whole bunch of coins a whole bunch of times, flip triplets, sets of 3 coins a million times and see what you get. And you'll probably get about 3/8. You might not get exactly 3/8. In fact, you probably won't get exactly 3/8, but you'll be in the ballpark for sure. And then the intuitive probability is what does your instinct tell you? Okay, and this doesn't mean it's going to give you the correct answer. Our instincts are often wrong. Our intuitions, especially in probability, are often wrong. But that is a valid form of probability to think about, is just intuitively, what do you think the probability of getting 2 heads might be? Lastly, excuse me, the complement refers to the event not happening. Okay, so we can talk about what's the probability of not getting 2 heads. And we put that bar on top of the event, and that just means not. Okay, because that's a lot easier than talking about the probability of getting 0 heads or 1 head or 3 heads, right? It's much easier to think about what's the chance of not getting 2 heads. So we can use that, the sample space as well. But the easiest way to think about it is just subtract off what we're taking the complement of. all probabilities always have to add up to a whole, 100% or 1. So in this case, we take our 1 and subtract off the probability of actually getting the 2 heads. Okay, and then we need to think about maybe common denominators, but we can do our subtraction and we get 5/8. Okay, as our answer there. So that's the probability of not getting 2 heads. Lastly, real quick, I just want to talk about probability versus odds. In this class, we'll almost always talk about probability. I really don't like, I don't think odds give us a good sense of the probability or the likelihood of something happening. They're a little counterintuitive sometimes. So the probability is the chance of success, and the odds are the chance of success to the chance of failure. Okay, so let's say we have a bag and there's 3 orange balls, and let's say there are 5 purple balls in there, and that's all in a bag, and we're reaching our hand into that bag and we're trying to pick one ball, and we're wondering what the probability is of getting an orange and then what the odds are of getting an orange. So the probability, the chance of success of orange, P of orange, is 3 out of 8. Okay, there's 8 total objects in there and 3 of them are orange. The odds are going to be 3 to 5. Okay, so the odds of getting an orange are 3 to 5. Okay, because this is the number of ways of getting an orange, and this is the number of ways of getting a non-orange. So chance of success divided by chance of failure, or with a colon and then chance of failure. You might think of the chance of success as being 3/8 to 5/8, and that's valid as well, but then we can really just multiply everything through by 8 and get our odds being 3 to 5 odds. Okay? But go with probability. I think it's a much more sort of intuitive, accessible way of understanding the likelihood that something will happen. And that's a good place to stop right there.